Question number 30. The diagram below represents the setup for an experiment for studying groundwater. Tubes A, B, C, and D contain equal volumes of sediments. Within each tube, the sediments are uniform in size, shape, and packing. A test for water retention was conducted by first filling each tube with water, then draining the water into beakers. Which graph represents the general relationship between the sediment size and the amount of water retained by the sediments after the tubes had drained? What they're asking here is what is going to work the best for stopping water or holding water. So they're asking, are large particles, like the one all the way over here, going to hold the most amount of water, or are the smallest particles in tube A going to hold the most amount of water? So this question really is, can you read a chart? That's how I take it, at least. Let's read the question. Which graph represents the general relationship between the sediment size and the amount of water retained by the sediments after the tubes had drained? Well, like always, the Regents likes to give you two bad answers. It's obviously not going to be this one, because if it was the same all the time, they wouldn't ask the question. And it wouldn't make sense that if the smaller sediments didn't retain water, and then the medium sediments retained a lot of water, and the larger sediments didn't hold any water. It just wouldn't make sense. So you can throw out 3 and 4 immediately. Now we get to 1 and 2. And you have to think about it, and the important thing is really, really reading these charts correctly. Now if you look here, it says as you go up, it's the amount of water retained. So the higher you are, whether it's over here or over here, that's where the most water is retained. And it's asking by which size. The smallest size is over here, and the largest size is over here. So you really have to make sure you look at these, and that's what the problem is. People try to rush a little bit, and they want to look at the direct relationship, and oh, this looks right. It always looks right. It fits, I think. When you ever see a direct relationship, it looks nice, so it looks like the correct answer. The correct answer here is 2. And the way that I like to think about this question is smaller particles, 0.03. If you go to the reference table, you can see over here. It's somewhere in between, sand and pebbles, so it's kind of small. But the way I like to think about it is that I like to think about sand. And I know I mentioned Hurricane Sandy earlier because this is when I'm recording this in 2012. It's just December right now, so maybe a month later. And sand is going to be able to stop the most water from going through. Okay, so you put sandbags around something so the water doesn't go through. If you were to stack boulders in front of your house, the water would go straight through it. Okay, it wouldn't hold any of that water. It wouldn't trap any of that water. So the correct answer here is 2, because the smallest sediments, the sand, is going to retain the most amount of water. It's going to hold the most amount of water, and also blocks the most amount of water from falling down into the beaker. So just like you would use sandbags to save your house or protect something, you can also use it to slow something from draining through. So the correct answer is number 2. The smaller the sediment, the more it will retain.